Alright, so this is our Honors Chemistry lesson video for 11.2, and this is part 2. So if you watched part 1, we were talking about the 5 types of reactions, and so those are synthesis, decomposition, single and double displacement, and combustion. So we already went through synthesis, decomposition, and single displacement, and so now we're going to do double displacement and combustion. And keep in mind, some books will call displacement replacement instead, and so that's fine, it's the same type of reaction. And remember, these aren't the only types of reactions, these are just 5 common types. So in a double displacement reaction, it involves the exchange of 2 positive ions between 2 compounds. So we would swap our 2 positive ions. So those are, of course, the 2 first ones, because the positives are always listed first. So a generic reaction would look like this. So A was with B, but now A is going to bond with D. C was with D, but now C is going to bond with D. And remember, the important thing is you always have to write the positive one first when you bond to the 2. And then here's an actual example. Na was with Cn, but now it's going to be with SO4, so Na and SO4. And H was with SO4, but now it's going to be with Cn. And the other important thing is to remember, when you are forming the new compounds, you don't need to worry about what subscripts you have on this side. You need to worry about what you need when you balance your charges. Because that's the most common mistakes I see, is people not balancing charges correctly. Alright, so let's look at a couple together. Don't forget to maybe try one on your own though once we get near the bottom. So, what I like to do whenever I'm doing a displacement problem, be it single or double, is I like to go ahead and label my charges on the reactant side. So calcium's positive 2, bromine is negative 1, silver is a transition metal, but since NO3 is negative 1, I know silver is positive 1, because of course I know they need to cancel out. So what's going to happen is my calcium and my silver are going to swap places. So they're not bonding together, they're both positive, they're swapping places. So now calcium is going to be with NO3. So I bring over the same charges, so Ca positive 2, NO3 negative 1, and so I'm going to cross my 2 down. And now silver is going to bond with bromine. Bromine only has this 2 though because it's bonded to calcium. So it's to help cancel out calcium's positive 2 charge. It's now going to be with silver, so I'm not going to bring the 2 over. I'm going to figure out what subscript it needs on this side once it bonds with silver. So of course I'm going to put silver first because it's the positive one, and then Br is negative, so when it's with silver it doesn't need a subscript. So again, I know it's hard for some of y'all to take away the 2 because you think, well, where did the other Br go? Well, remember, we have to balance the whole equation to make it accurate. Okay, so I have 1 Ca, 2 Brs. Here I only have 1 Br, so I just need a 2 in front. 2 Ag, but here I only have 1 Ag, so I need a 2 in front. And then I have 2 NO3s and 2 NO3s, or 2 nitrates. Alright? And so that's all you have to do. So the problem is remembering to balance your charges, making sure the positives first, don't accidentally bond to the 2 positives. There's lots of little things you got to remember to do these. Double displacement are the ones that people have the most trouble with. Alright, so now let's look at our second one. So again, I'm going to write my charges first. Fe's transition, so I know S is negative 2, so Fe has to be positive 2. H is positive 1, and Cl is negative 1. So I'm going to take my 2 positives and swap them. So Fe and H are going to swap. So now Fe is going to be with Cl. So Fe is positive 2, Cl is negative 1, so I cross that 2 down. So see, if you'll go ahead and write your charges on this side, you can just bring them over to this side. Alright, now H is going to be with S, but I'm going to put H first because it's positive. So H positive, S negative 2, so I cross that 2 down. And so if you're having trouble figuring out how to balance charges, you need to go back to chapter 7. Alright, so last step is, well, where did this extra H and Cl come from? I just need to balance it. So I have 1 Fe, 1 Fe, 1 S, 1 S, 1 Cl, 2 Cls, so I need a 2, and then 2 H's and 2 H's. Alright, so maybe before I do the last one, try it on your own. Pause the video. I'll assume you've done that, and now let's look at it and see if you got it right. Alright, so I would put my charges first. So sodium is positive, hydroxide is negative, that's on your polyatomic ion sheet. NO3 is negative, but there's 3 of them, so that's like negative 3, so iron's going to be positive 3. And so then I just swap my 2 positives. So now Na is going to be with NO3, but remember, it only has this extra 3. because I was trying to balance charges with iron. It's not with iron anymore, so I'm not going to bring over that extra 3. So we have Na positive, NO3 negative. So see, when it's with sodium, it doesn't need an extra subscript. So now Fe is going to be with OH. I'm going to put Fe first though because it's positive. So Fe positive 3, OH negative. So don't forget, we need 3 OHs, but it's still a polyatomic ion, even though it doesn't have its own subscript. So it has to have parentheses. All right, and so then the last step is I need to balance it. So I have 1 Na, 1 Na, 1 hydroxide, which is OH. Remember, I like to keep polyatomic ions together. I have 3 hydroxides on this side, so I need to put a 3 over here. So now I actually have 3 Nas, so I need to put a 3 over here. Whenever you change something, if it alters an element you've already balanced, I always like to go back and fix that element before I keep going, because otherwise I might forget later. All right, so I have 1 Fe, 3 nitrates, and 3 nitrates, just like that. So hopefully you got that one right. Okay, so let's move on to our last type, which is combustion. All right, so remember, our first reactions, they can kind of be based on relationships. So synthesis is like marriage. 2 people are separate and then they come together. Decomposition is like divorce. 2 people are together and then they separate. Single replacement is like that newer, more attractive woman walks by. And so what happens is the man leaves the woman he was already with for the newer, attractive woman, and then the older woman was left behind. So see, something is single on both sides. Double displacement is kind of like the show Wife Swap. Okay, the 2 men, they swap wives, so swap positive ions. All right, and so those can all be described by relationships. Combustion is kind of its own category. So a combustion reaction occurs when a substance burns in oxygen and produces a lot of heat and light. So these are the exciting reactions where you have like fire, explosions, things like that. And so what you're looking for is something reacting with oxygen. Now sometimes combustion reactions can also be another type. Like this one is also a synthesis reaction. So because sometimes they can be multiple types, I tend to give you the ones where it's a hydrocarbon. A hydrocarbon is just a hydrogen and carbon bonded together in a certain amount. So I'll tend to give you ones like this. Whenever a hydrocarbon burns in oxygen, you're going to get carbon dioxide and water as your products every time, as long as it's complete combustion. You can have incomplete combustion and that gives you carbon monoxide. But I will usually give you ones where it is a hydrocarbon and oxygen, and so you'll know that the products are carbon dioxide and water. So mainly for combustion, you can look for a bunch of C's, H's, and O's. But like I said, there's technically other examples, but I just don't like to give you those where it can be synthesis or combustion. I don't like to give you the ones in that gray area. So many combustion reactions involve a hydrocarbon burning in air, and the products are CO2 and H2O as long as combustion is complete. So this is our generic reaction, because these subscripts for the C and H can be anything. And sometimes you'll even have a reactant that also has O in it, like we could have glucose, C6H12O6, plus oxygen, making carbon dioxide and water. The hardest part about combustion is usually the balancing, because this is where you have a bunch of those weird doubling ones, which I personally love. All right, so let's look at a couple together. So it says, predict the products for the following reaction. Well, once I see that it's a hydrocarbon and oxygen, I know it's combustion. It's not going to be single replacement. So I know I'm going to get CO2 and H2O. And so then I just have to balance this thing. All right, so I have 6 carbons. I have 1 here, so I'm going to put a 6. Here I have 6 hydrogens, and I only have 2 right here, so I'll put a 3. And so now we have oxygen. This is where it's going to have that doubling. So if you didn't understand that in the previous section, hopefully you'll catch on to it now. So I have 2 oxygens over here. Here I have 12, because 6 times 2. And then here I have 3. So I have 15 on this side. Now again, since I've already balanced everybody else, what I'm going to do is just go ahead and put a decimal. So what times 2 makes 15? 7.5. And then I can just go back and fix the decimal. So again, everything has the correct ratio, I just don't want a decimal. So I multiply everything by 2. So remember, this is an understood 1, so 1 times 2 is 2. 7.5 times 2 is 15. 6 times 2 is 12, and 3 times 2 is 6. And so if you look, everything's still balanced. So now I have 12 carbons and 12. I have 12 hydrogens and 12. I have 30 oxygens. Here I have 24 plus 6, which is 30 oxygens. Okay, so sometimes the combustion ones can just be tricky to balance. All right, but like I said, sometimes it's not just a hydrocarbon. The initial substance can have oxygen in it too. It works the same way. It's still going to make carbon dioxide and water. It just makes it a little trickier to balance. So it says write the balanced equation for a reaction that occurs when methanol, which is CH3OH, is burned in air. Once it says it's burned in air, that means it's going to react with the oxygen. So that's how I know it's combustion. So I'm going to start with my methanol, CH3OH. I'm going to add oxygen to it from the air. And because it's a combustion reaction, and I know it's combustion because it's burning in air, it's using the oxygen, it's going to make CO2 and H2O. So you just have to kind of remember those are the products. So now I need to balance it. So I have one carbon. Got to be careful on hydrogen. I have 4 hydrogens because I have 2 and 1 more. 4 hydrogens, but here I only have 2, so I needed 2. Now I got to look at oxygen. So I have 3 oxygens. All right, so I have 3 oxygens on this side. Here I have 4 oxygens. So it's like I got 3 on one side, 4 on the other side. I haven't fully finished balancing yet, so what I'm going to do is I'm going to start by doubling the odd one. Okay, so remember, we talked about this in the balancing equation section. So I'm going to have to go back and fix some things, but I'm going to double this oddball oxygen and then see if I can fix everything else. Okay, because I did that, I need to go back and fix C and H before I worry about O again. Okay, so see, now I have 2 C's, so I'm going to put a 2 here. Now I have 6 and 2, which is 8 hydrogens. So you can see how this is 4 together times 2. So I have 8 hydrogens, so this really needs to be a 4. And so now I can look at my oxygens. So here I have 2 and 2, which is 4. Here I have 4 and 4, which is 8. So see, I have 4 right here, I have 4 right here, so I have 8 on this side. Now I don't want to, I can alter oxygen by changing this coefficient or this coefficient. I don't really want to mess with this coefficient because then I'll keep messing up carbon and hydrogen. So really I only want to change this one. So I need 8 oxygens. I already have 2 right here, so that means I need 6 more. So what times 2 gives me 6? 3. Okay, so sometimes that's what's going to happen with oxygen. You're going to have different amounts on both sides, but you may have options of where to put a coefficient. Well, just try to put a coefficient where you're going to mess up the least other elements. So once I realize I have 8 on this side, I already had 2 right here, I need 6 more in that location. So that's why I put the 3. So like I said, the combustion ones, they're just kind of hard to balance sometimes. So let's look at the bottom one. Maybe try it on your own first, and then we'll look at it together. Pause it. I'll assume you've done that. All right, so it says write the balanced equation for the reaction that occurs when ethanol, which is C2H5OH, is burned in air. Okay, so we have a similar setup as this. So this time we're starting with C2H5OH. When something burns in air, that means it's reacting with the oxygen. So because I know it's combustion, I know my products are CO2 and H2O. All right, so let's get balancing. So I have 2 carbons here and only 1 here, so I'm going to put a 2. I have 6 hydrogens. Okay, 6 hydrogens. So 3 times 2 gives me 6 hydrogens over here. And last is oxygen. Let's see if it's a problem this time. On this side, I have 3 because I have 1 and 2 more. So I have 3 on this side. On this side, I have 4 and 3, which is 7. Now, before you start thinking like, how do I go between 3 and 7? Remember, it's everywhere. Okay, I have 4 and 3, which is 7 on this side. So remember, I can either put more oxygens by putting a coefficient here or here. But if I put one here, I'm going to mess up carbon and hydrogen. So I'm just going to say, okay, I already have 1 right there. I need 7, so that means I need 6 more. So what times 2 makes 6? 3. So see, now I have 6, 7 on that side. Okay, so like I said, combustion, just sometimes you got to be real careful about how you balance. But otherwise, coming up with the products is it's a hydrocarbon that is combusting. All right, so section assessment. What are the 5 types of chemical reactions? I'm not going to write all of them out. You already wrote them, or they're already earlier in the section, but it's synthesis, decomposition, single replacement, double displacement, and combustion. So number 2 says classify the following reactions. So we just need to say what type they are. So part A, I can see it's a hydrocarbon, burning an oxygen, it's making CO2 and H2O, so that makes me think combustion. For part B, I can see it's one compound splitting up. So see, one thing splitting up like a divorce, so this one is decomposition. All right, here I can see this is lithium reacting with oxygen to form one product. So 2 things separate coming together as one, so it is synthesis. However, because it is lithium reacting with oxygen, technically this is also combustion. Okay, so that's why I say for me, when I give you combustion, I'll stick with the hydrocarbons so it's obvious what it is, because technically this one falls under both. All right, and then our last one, I can see that zinc is single and silver is single, so I can see there's something single on both sides, so this one would be single displacement. Single displacement for that one. All right, so let's move on and do some where we have to make the products ourselves, because those are the ones y'all struggle with. This right here was easy. All right, so it says complete and balance each equation. So it doesn't tell me I have to say what type it is, but we're going to say what type it is just to give you some practice. Because I'll go ahead and tell you, this is the way it is on the test. I tell you to tell me what type and make the products and balance. Okay, so here, because both of them are paired up, that's how I know this is going to be double displacement. It's helpful to figure out what type it is before you start so you can figure out how the products are going to work. So I know in double displacement I need to switch my 2 positives. So I'm going to go ahead and label my charges. So Ca is positive 2, I is negative 1, NO3 is negative 1, but there's 2 of them, so Hg is going to be positive 2. I'm going to swap my 2 positives. So now calcium is going to be with NO3, so I have Ca plus 2, NO3 minus, so of course I need 2 nitrates. And I can see that Hg is now going to bond with I. I'm going to put Hg first because it's the positive, I second, and I need to cross that 2 down. I need to balance it, but if you look, it's already balanced. Ca, Ca, 2 I's, Hg, Hg, 2 nitrates, and 2 nitrates. All right, like I said, double displacement are the ones that y'all tend to struggle with the most. All right, so next we have Al and Cl2. The only option is for them to come together in synthesis. All right, so this is going to be synthesis, but you have to remember when you bond them, you have to pay attention to the charge. So aluminum's positive 3, so I'm going to write that one first since it's positive. Cl is negative 1. Remember, I don't bring the 2 over because it only has the 2 right there because it's a diatomic and it's by itself. So I cross my 3 down, and then last I need to balance it. So I have 3 Cl's and 2 Cl's. So remember, I told you the easiest way to fix a 2 and a 3 is make them both 6. So 2 times 3 gives me 6. 3 times 2 gives me 6, but now I have 2 aluminums, so I would just put a 2 right there. Okay, you may want to pause the video and try some of these on your own though, instead of just watching me do all of them. All right, so part C, I can see that something is single and something is bonded, so that makes me think single replacement. So I'm going to put my charges. I gave you a hint, silver is positive 1 since it's in the transition metal area. H is positive 1, Cl is negative. So that means Ag and H are not going to bond because they're both positive. Ag is going to bond with Cl. So Ag is positive, Cl is negative, so I don't need to cross anything. And now H is going to be alone on this side because remember, single replacement has something single on both sides. However, when H is alone, it's a diatomic, so it needs the 2. All right, so then I balance. So I have Ag, Ag, Cl, Cl, H, and 2 H's, so I need a 2 here. But now I have 2 Cl's, so I need a 2 here. But now I have 2 Ag's, so I need a 2 here. And that's all, so hopefully you got that one right. All right, so our next one, I see a bunch of C's, H's, and O's. I see it's a hydrocarbon reacting with oxygen, so that makes me think combustion. So I know in a hydrocarbon combustion reaction, I'm going to form CO2 and H2O. So see, there's no like crossing of charges and forming products in combustion. You just have to remember it's a thing. So now I need a balance. So I have 2 C's and 1 C, so I put a 2. I have 2 hydrogens, 2 hydrogens. I have 2 oxygens, and I have 5 oxygens. Oh my gosh, if we can't get past the doubling. So what times 2 makes 5? 2.5. But of course I can't have a decimal, so I need to double everything. So my 1 becomes a 2, my 2.5 becomes a 5, my 2 becomes a 4, and this 1 also becomes a 2. And so then you can see that everything is still nice and balanced. All right, so last one, I can see there's 1 reactant, so the only option is for it to split apart in decomposition. So I need to split it up. So I'm going to get Mg. Mg is not a diatomic, so it'll just be 1. And I'm going to get Cl. Cl is a diatomic, so I'm going to get 2 of them. And then if you look, it is already balanced. All right, so those are the 5 common types of reactions. The hardest one for most of you is double displacement because there's a lot going on. If you are not good with forming compounds because you're not good at balancing charges and things like that, again, you need to go back to chapter 7 because that's where we covered how to do that.